Soil engineering. What the heck is that? Is it like gardening but with hard hats and fewer gnomes? Well, basically, soil engineering or geotechnical engineering is about understanding dirt so buildings, roads, and bridges don't fall over. How do engineers know if the ground can hold a house or a frickin' skyscraper? They test the soil's strength, compressibility, and how water moves through it. Sounds boring, right? But what if that boring stuff keeps your house from sliding into a river? Pretty important, huh? So what do they actually do to the dirt? First, they dig and sample it. Boring, hey? And run tests. Grain size, Atterberg limits for clays, and field tests like the SPT or CPT. Why measure all that? Because clay behaves differently than sand when you try to build on it. Ever wonder why some buildings sink or crack? That's soil being a jerk. And when soil is weak, engineers fix it. How? By compacting it, adding stone or grout, driving piles down to stronger layers, or installing drains to remove water. They also design foundations so the load spreads out. What about slope stability? They build retaining walls, anchors, or change the slope angle. If you don't control groundwater or consolidation, you get uneven settling and suddenly your front door is a slide. So who decides what method is best? Geotechnical engineers weigh risks, costs, and the site's behavior. It's a mix of science, judgment, and sometimes educated guesswork. Isn't it wild that the stuff under our feet is so complicated and that knowing it can save lives and money? Would you trust a building without a soil report? I wouldn't, unless it was on solid ground like my couch.